Okay, in the Zoom, can you hear me?
Yeah, we can hear you.
Great, thank you. Okay, howdy everyone. Howdy. So, okay, today we will have a quiz on the web assign, and the password for quiz 5 is data, DATA, which is for lowercase letters, and it will be offered at the end of this lecture, which is 2:45 to end of the day, 11:59. But as usual, yeah, actually, at this time, it will take a little bit longer than usual because it contains a 3 program. So I hope that, yeah, I will give you 30 minutes on the quiz. So please, yeah, be prepared. So that what it means that if you just start your quiz on 11:50, then you will have trouble because you only have only 9 minutes to complete the answers. So please start at least before the 11:30 to get the full time, right? So, okay. So you can see it on WebAssign as usual. And if you have any technical problem using WebAssign, then yeah, please let me know. And from Grace, is the quiz open note? Yes. So I will say it clear that every quiz on the WebAssign or eCampus will be open note except your exams, right? So except your exams, every quizzes will be open note. And so you can freely refer whatever you want, except the calculator, right? So usually I just want you to do it by yourself, not your calculator like Wolfram Alpha. So yeah, so please use the special lecture notes if you want. Yeah. Okay, do you have any other question, please?
Sure.
Great, then let's start with the chapter 7. So in the chapter 5, we know how to deal with a data with one variable. And in chapter 6, we deal with the two data and their relationships, right? So we just run using correlation, and we just run how to interpret the relationship between two data. And now in chapter 7, we will deal with how can we make such a data which is reliable for our decision, right? So that's the name of chapter is data for decisions. And to deal with this, first of all, we need to figure out what we want to measure and what we can actually measure. So for example, the population in the statistics is called the entire group of individuals about which we want information. So for example, if you want the information about the weather in Paris station, then population is weather of every day. So weather, if your population is weather in Paris station, then it means that just weather information in every day, right? Station, right? So if we have such information about the everyday weather of the car station, then definitely we can, combine those data and we can analyze that data using the knowledge from chapter 5 or chapter 6. But when you think about this example, can you gather all weather information in every day of car station? Maybe if you are a person who lived from when Earth created, then maybe you can at least know every day's weather information from station from the start of the Earth created to right now. However, even if you in that case, we still don't know the future weather information, right? Because we didn't live future right now. So even in this case, yeah. So we cannot gather about some, for example, future weathers, or so for example, or the weather in the long ago. So for example, before human exist, we cannot know the weather localization at least these two data, right? So from this, the statisticians actually think about how can we get some information about the population, the entire group, for example, in this case, weather localization, from the samples. So sample is just part of the population. So it is not the whole data, but part of the data, which we actually can collect information and use it to draw a conclusion about the whole, right? So since it is almost impossible to see the all data, we just gather the part of the information from the population, then we can just draw some conclusion from the sample to about the population, right? Does it make sense? So, and sampling is called just the process of choosing a sample from the population, right? So if you think about such a sampling issue, then first of all, you need to pick, data, not given on your preference, but fairly, right? So for example, I just want to know how of this class, which foods are most preferable for person in this class. But if I already asked you about the people in classroom already, but not in the Zoom, then it should be biased, right? Because maybe Zoom people has another preference, but I didn't care about that without any reasonable argument. Also, if I already ask such information or already survey on such information on specific genders, then it also gives us some biased information, right? Because one gender doesn't represent the other genders. So in such a case, we say that it is bad sampling or it is biased. So if it systematically favors certain outcome, so it means that even if the whole population may not have such a certain outcome, but when our sampling process just excludes some part of information, then we say that the process of sampling systematically favors certain outcomes, so it is biased, right? So, and in the section 2, there are two, bias examples are introduced. So first one is a convenience bias. So convenience sample. Convenience sample is a sample of individual, but just collecting information from the data or from the people, we can conveniently get, right? So for example, if I want to study about the population in the Texas A&M University, but when I just ask such information to my class already, then it is a convenient sample, right? Because I can reach you a little bit easier than other Texas A&M University people. So I just asked you about the opinion on the population on Texas University, but that's convenient sample because I just asked you not because it is the good sample, but because it's convenient for me to ask you instead of doing the other, right? So that's the convenient sample. And the other bad sampling method is voluntary response sample. So it means that okay, so let's go back to the example about the food for what is the prepared food for this class. And when I survey on that food, maybe I can say that, please raise your hand and say something about what is your preferred food. Then maybe some people who had good intention definitely raise your hand and say something about that. But some people who are shy do not say anything about the issue, right? So it discriminate the people who are not shy and people who are shy on this case. So in that case, we say that the sample just chosen by responding, chosen by someone who appealed to their opinion is called voluntary response, right? So in that case, we need to ask people to, not only ask people to guess the response, but also we need to care about some people who didn't give an answer, right? So to get the, to avoid such a systematic paper result. So in this section 2, what we need to do is just see about such an experiment or such a data sampling, and we want to ask, just find what kind of bad sampling here or not, right? So first example is about the shopping. So in a study of the shopping habits of others, we asked 250 people as they exited a grocery store about their total purchase, right? So in this case, what is the population? Percy? So population is just others, maybe in the world, but we just put in the US, right? For example, population is our others. And here sample is 215 people exiting a grocery store. But is it convenience sample? Yes, because, let me see. You're right, yeah. What did you mean? As Carrie says, maybe you can just go to HEB or some, Walmart and just ask people about that, right? It is definitely much more convenient than ask people who are in the other states or who are shopping in the online or something like that, right? So definitely it is convenience example. So we ignore people who do not use the grocery store, right? And is it a voluntary response sample? Maybe, but maybe not, because if they study about the asking people only who responded their question, then it is a voluntary sample. But if the study is actually kind of the first one, so everyone in the grocery store should write down some surveys before exiting, then in that case it is not the voluntary response sample. So it depends on the how they correct their data, right? So it will be not, if the prompt give information, we didn't determine whether it is a voluntary response sample or not. But so the possible bias is that we ignore people who then use the grocery stores or use other grocery stores. Or since we are actually interested about the shopping habits, not only shopping habits on grocery store, but also shopping habits in other, other purchases. So maybe we also do not care about use internet or other purchases, right? So here are such a bias happens, right? Does it make sense? Or do you have any other question or comment? Mm-hmm. But there are questions. So yes, so the Abud, right? What Abud asks us is that, is there any question which determine whether the bias is more easier for bias? Yeah. Oh, yeah, that's a good question. And my answer is yes. So, for example, in my case, I just think first about whether this sample is chosen fairly. What I mean fairly means that, for example, when we just investigate about the people, then I definitely care about just pick each person in each gender and each ages, and also each status, like first year, second year, third year, and fourth year from the population, right? So it means that they are uh, fairly delivered. Oh, no, fairly divided, right? So when you see such a study, then first thing you can ask about this study is that it, does they choose the people or choose the data purely from each section we can imagine? So like each section of gender, or each section of age, or each section of statuses or other characteristics. Then you can figure out whether their examples are biased or not without using such a sample issue. So these two sample, convenience sample and voluntary response sample, is just two most obvious bad sampling from the future, but there are a lot of other biases definitely here. Does it make your question? Great. Okay, so let's deal with the next question in example 2.3. So in order to determine if students on college campus are in favor of a tuition hike to pay for expanded parking service, a member of Student Senate surveys 25 people in a commuter parking lot. And in this case, the population is students on college, right? Because we will determine something for the students on a college. So this student at this college. But our sample is 25 people in commuter parking lot, right? Again, is it fair? Can you see that this 25 people in the commuter parking lot represent all the students in a college? Usually not, because, for example, not every student has a car, right? Also, maybe even they have a car, but maybe a lot of students uses the other parking lot instead of the commuter parking lot, or some of the students actually, yeah, maybe if this 25 people is the all student in a college, then it makes sense, but usually it may not, because college have at least 100 or 1,000 students usually. So in this case, we can see that this is a convenience example, because just asking people in the commuter parking lot is much more convenient than asking for all population in the university, which uses other parking lot or which uses the other commuting system like a bus or a train or something like that. So that's convenience sample. So, and another issue which I didn't introduce in the previous, but here is that it only have 25 people, right? So we don't know what the entire population of the at college, but usually, yeah, if you think about this Texas A&M, then we will have at least 20,000 students, right? In undergraduate and including graduate students, we will have 30,000 or something. So in this case, 25 is definitely not enough for representing some numbers, right? So yeah, so it is not in the exam, but usually in the statistics, uh, we need at least, it depends on the sample size, but we need at least 1,000 data are needed to get enough sample. But there may be other techniques using, from small data to get some good samples. But yeah, usually they say that at least 1,000, data are needed to get some statistically consistent sample. So here biases, one is they ignore people who do not use commuter packing rat. For example, people may use was train or something else, right? And the second one is that sample size is too small compared with the population size. So for example, TAMU has at least 20,000 students in here, but it is a little bit difficult to 25 students, yes, represent all 20,000 students, right? Okay. Oh. Is it good? Yeah, in the next example, on October 20, October 12, 2011, a quick poll on CNN.com asked, has the BlackBerry outage affect you, right? So in this case, what is the population? If you ask someone that has the BlackBerry outage affect you, then what kind of assumption you have? BlackBerry users, right? So if you don't have, for example, if you use iPhone, but I just asked you about how BlackBerry affects you, then it does not make sense, right? So definitely CNN assumes that the population is BlackBerry user, right? And in this case, sample is not clear, but whoever responses the survey, right? So in this case, we can say that it is a voluntary response sample. Because you don't know which person who used the BlackBerry actually responses, or sometimes maybe even if you don't use the BlackBerry, but yeah, they can use, they just answers about the questions. So yeah, maybe I'm a South Korean user. So do you know about the Chex, which is cereal, which is chocolate cereal? So okay, maybe it's like a Comfort in the in the United States. So there are something called Chex here. Okay, I can just see you because it's a I will share this Google. So yeah, I know that this is South Korean, but I just explain you what happened. So for the first one is just Checky, which is just one of the cereal model in South Korea. So it is just coated with the black one, and it is usual cereal like a compost was like usual, cereal for the children. And in that case, actually, it is actually from the Kellogg, which is United States, cereal company. So, and they just give some event for children about whether they choose the choco choco, a choco taste, or whether they choose the, very kind of garlic taste, right? Yeah, actually it is green onion taste, but so they just want children to ask whether you choose the black chocolate taste cereal or whether you choose the black onion taste cereal, right? So in the children's mind, they actually expected that every children likes the chocolate instead of the green onion or some other things. So they just think that definitely children takes the first one instead of the second green onion taste, right? But all the others at the time ruined that event. So all the others actually voted about the green onion taste because of just ruining their event. So actually, green onion taste was chosen at the poll, but Kellogg doesn't make it because definitely it doesn't. Nobody likes the green onion like a cereal at that point, so they didn't make it. But recently, after 20 years after the event, they recently made such a things because a lot of South Korean users at that time request them to make the green onion taste. And definitely people hate it. But anyway, so that's the kind of the example about the voluntary response sample, right? So when you are maybe when you go to some company like a Kellogg and give some event about that, then definitely you need to be careful about the other orders who want to ruin your event. So that's the one sample, one example about the green voluntary response example. Okay. So in the example 2.4, it has bias that maybe shy BlackBerry user do not respond to the 4. And sometimes maybe some non-users or some other people who do not use BlackBerry maybe some non-users answers is actually answers about their fake experience, right? So these are two biggest bias in this example, right? Okay, do you have any question or concern? So yes, so in section 2, if you can see some bias from the given sampling, then you are fine, right? Even if you don't know the name, but yeah. But these two voluntary response sample and convenience sample are two most common bias in the sample, even if in the company works. So be careful about that. In section 3, so in that section, we just learn how can we make a random sample which is not biased for anyone. So a simple random sample, so it is the most simplest one when you deal with the data. So the simple random sample of size n is consists of n individuals from the population chosen in such a way that every set of an individual has an equal chance to be in the sample, right? So for example, if I want to, investigate about which one get the COVID-19 or which one is not, so in the start of semester, university gives us from some random sampling for testing COVID-19, right? Maybe you remember about such an event. Then in that case, what the university says, takes that is just make some virtual lottery, and they give the 1/n probability for each student, and they just choose some sample to be tested, right? In such a case, we say that it is a simple random sampling. So that's why they say that it is random testing for COVID-19. And it is very efficient, especially when you have no resource to test everyone. Then you can just pick some randomly samples. Then you can just test the sample population for sample individuals for testing COVID-19. So it is usually done. And so what you need to do is to make a sample have no bias, which means that you can just purely choose each individual in your population, right? So first example in 3.2, in a class of 25 students, every student's name is placed in a box and 5 names are drawn at random. It is just example of simple random sample. Yes. But in case maybe I just write down someone's name twice and I just put such 2 papers in the box and just choose it, then it is definitely not a random sample, right? Because the someone who has named two names are in the box will be chosen, have a probability which is twice of the other person's, right? So in this case, it's yes, but in other cases, it's not. So it is very important to pick some data or pick some individuals from some given, with some random equally chosen, equal chance. So first thing we can use in this is table of random digits. So honestly, in these days, you can just choose make a random sample using Excel or using Python or anything else. So I personally prefer to use such a things, but since it is required as your basic courses, so we will study about the using table of random digits to figure out the data. So instead of reading the direction, maybe it is much more easier for just doing by hand. So for random for such a table random digit method, first of all, if you have some data, then what you need to do is give them labeling, right? Give the data label, right? And if your data size, if your size of data is less than 10, you can label it as 0, 1, 2, 3, 4, 5 to 9, right? And if your data has size greater than 10 but less than 100, or less than equal to 100, then you can label it as 0, 0, 0, 1, 0, 2, 0, 9, 1, 0, 1, 1, 1, 2, and 9, 7, 9, 8, 9, 9, right? So using those 2-digit numbers, you can label your data, right? And again, in case of size is greater than 100, but less than 1,000, you can do the same thing for 3-digit numbers, right? 000, 001, 009, 010, and 099, 100, 101, 998, 999, right? And so on, right? So you can do, yeah, if your size of data is greater than 1,000, then you can use the 4-digit number, right? To labeling your data. So for example, in example 3.5, we have 20 data of the name. And I just want to choose the person randomly from this data. So what I did is just first labeling this person using 2-digit numbers, right? Because the size of the data is less than 100, right? But greater than 10. Does it make sense? Or do you have any question on such a labeling? Good. Okay. So when you just finish your labeling, then choose the row number of table of random digits. So here is example of table of random digits. So in this case of table of random digit, they are intentionally made to the chance that if you just choose numbers by line by line, then it will give you just equal chance for each number to be chosen. So for example, since we are in this example, we use line 103 because 103 is in the chosen by the example. So start with line 103. Then since our label is 2-digit, right? So just read your 2 digits equally. So first one is 35, but definitely we don't have 35, so just delete it. And next one is 48, but definitely we don't have any 48, so delete it. And next one is 65, right? But we don't have any 65 in our label, so delete it. Next one is 95, but we don't have any 95 in here, so delete it. And the next one is 00. And I think the 00 is the starting point, but we started with 01, so sorry about that, because, yeah, so but in this case, 00 is not here. Yeah, but usually in computer science, we start with 0, so that's why I like confusion, but sorry for mistake. But anyway, so in this example, since we don't have 00, so just delete it. And next example is 20. Then now you can find 20, right? Thompson. So the first person chosen by this random digit is Thompson, which is 20. Pardon? No, it doesn't matter. It doesn't matter. So you can just write down with the label first. So for example, you can just write down label 20 Thompson. Right? So it doesn't matter because the one thing which matters is just we choose the person Thompson, right? So, yes. Mm-hmm. And next one is 06. And again, 06 is our example, which is Paul. So second person is 06, Paul. And next one is 08, 6008 is here, which is Harris. Hannah asks, why are we going by 2 digits again? Because our label is 2 digits, right? So if our label is 3 digits, then we will do it by 3 digits, right? But since our size of population is less than 100, so our label size is just 2 digits. So that's why we choose only 2 digits for random table. Does it make sense, Anna? Okay, great. And next one, 97, definitely not in our examples, so just delete it. 69 is not in our example, delete it. 54 is not in our example, delete it. 87 is not in our example. 07, but 07 is here, right? 07 is good man. So first person is good man, right? So that's the table, the way of finding simple random sample from table of random digits, right? So if your random table is, randomly distributed, then the numbers in random table is randomly distributed, then you are fine, right? So, and we don't ask about whether your random table is really random or not, but so you don't need to worry about this. Do you have any question on this method? Okay. Okay, example 3.6. So if we have a class has 100 students, then how long do the label for on SRS need to be? So in this case, maybe you can use the 2 digits, like 00, 01 to 99. Or yeah, if you just start with 01, then you need to use 3 digits, right? So it depends on your choice, but I think that, yeah, I think that in this case is kind of boundary cases. So yeah, so both are fine. So both are fine. So you can use from 00 to 99, or you can use 001, 002 to 100, right? So both are fine. And if there is 5 students, what would the label look like? So in this case, we need at least 4 digits, right? So it should be 0, 0, 0, 0, 0, 0, 0, 1, 1, 4, 0, 4, 1, 4, 0, 5, right? 1, 4, 0, 4 in this case, if you start with 0, or if you started with 0, 0, 1, then it ends with 1, 4, 0, 5. So when you start with 0, then just -1 on your total population to get the last number. So these are all questions about the labelings. Do you have any question on labeling? Okay, then let's deal with another example. So here we have 2,452 students. Wow, that's a lot of students. So starting at line 122, which is third line from the top, in the table below, choose a random sample of 4 students, right? So in this case, since, yeah, it is a little bit difficult to write down all 452 students in the name, so we just assume that we label those students. I just choose starting from 1 because yeah, maybe you are confused about the starting with 0. So I just want to label it from 0001, 0002 to 200, 2,452, right? Then starting from 103rd line, the first 4 digit is 3227, but definitely 3227 is greater than 2452, so we cannot choose it. And 4674, we cannot choose it because 4,000 is greater than 2,000. And 9221 is also, we cannot choose it because, there's no 9,000 something in the hour level. And 6253 is also, we cannot choose it because we don't have, 60,000 something, 6,000 something. And then you can get 0298. Now here our level is from 1 to 24,452. So per student we need to pick is 0298 level, right? Okay, Joanna, can you go back up? Which part do you want to ask?
Just up a little bit higher. I missed this part.
Sample of the behind?
No, up above it.
Above it, yeah. Here, what I said is that we can just choose the 2-digit labeling, or you can choose the 3-digit labeling, which is your choice, right? But in the last case, you can choose, start with 0 or start with 1. So each also your choice. But when you start with 0, you need to be careful about the last number because last number is not the same as the total students, right? Does it make sense? Or do you have any other question? Oh, and Morgan questions about why are we using 3-digit? Because we have 2,052 students, right? Because, yeah. So in this case, if you use only 3 digits, then you can only give them from 0001 to 999, right? So we can only, at least we can give only 1,000 students with the different levels, but there are another 1,452,000 students left there, so that's why we need to use 4 digits. Does it make sense? Okay, then let's go back to the table. So we choose 0298. So next one is 1585. And again, this 1585 is less than 2452. So we can choose it, 1585. But still we need to choose 2 more students. So let's go to again. So now you can have 5, right? But there is no other number in the right side, then you can just go down low. So go to the next row, then you can see the 5978. But again, 5978 is not in our level. So, and next one is, so just delete it. And 8631 is also not in our level. And 4809 is not in our level. 6611 is not in our level. 3903 not in our level. The reason I can do it for fast is because I just see the first number, right? Because our students has only 2,400, so first number should be 2, 1, or 0, right? Otherwise, it cannot be in our example. Then next one, we had 1315. Again, in this case, 1315 is definitely less than 2452. So you can choose 1315 from here. Then next one is 2540. It seems that it is in here, but actually it's not because 2050 is greater than 2040, so 24540 is not in here. And the next example is 1352. And again, it is in the our Rabbit. So 1352 is here. So we are done. Right? Does it make sense? Or do you have any question? Good. Okay. Then let's go to the next example. So in next section about is just there are some cautions about the sample surveys. So first thing is called undercoverage. Undercoverage occurs when some groups in population are left out the process of choosing the sample, right? So for example, when I just do make a simple random sampling, but I only give you labels on specific gender, but not in other genders, then it is actually the example of undercoverage, right? So for example, give labels to specific gender, for example. That's the example of undercoverage. And also non-response. Non-response occurs when individual chosen for sample can't be contacted or refused to participate. So even if you choose all the rabbits, but if you just contact some person who with this rabbit, but they do not respond to your question, then actually it it is not even random, because in that case we can just make a voluntary response sample, right? Because only we can measure is just someone who can respond to our question, but we cannot. But someone who didn't respond to our question, we didn't know about their status. So in that case, we can have also some bias, right? So that's the second caution we need to worry about that. So we can see some examples. How can we find such a bias? So for example, first one in example 4.2, a political survey is done via telephone by calling landline between 6 p.m. to 8 p.m., right? So is this SRS? No, right? Because, so for example, yeah, definitely there are some people who works from 3 p.m. to 8 p.m., right? In that case, they cannot respond, right? There are some people who works. So they cannot respond, right? So it gives us non-response issue. Also, it is actually called by landline, right? But actually in these days, not many people, including me, have the landline phone, right? Instead, they have cell phone, right? So actually, the people without landlines, for example, people already having cell phone, are not counted in the sample, right? Measure for sample. So in this case, this is case of under coverage, right? So these are two main things. And maybe if you just record the previous sample, bias sample, for example, convenience one or voluntary response sample, then maybe this is also related to voluntary response sample because of long response. Because some people, maybe you have such experience or not, but some people like me, that I just get the call from, some poor company, and they said about, do you like Trump or Biden or something like that? And sometimes I just hit, right? I didn't ask her about that. So I make the expose a little bit voluntary response sample, right? I'm just sorry about that, but yeah. So that's the one reason for having voluntary response. And also, maybe because of time, it means that it is just convenient sample, right? Because they use the time from 6 to 8 p.m. because they can just reach some people at that time, right? But if you want to reach people for other ones, then you need to reach for people in other times, including daytimes. So maybe examples convenient sample. So as you can see, they are almost impossible, especially in the social science situation, to have the 100% random sample test, right? So there are other, if you just run statistics more in the future, then you can learn about so many techniques to avoid such a, bias from the sampling. But here, to do this, you need to figure out that first whether what kind of biases can be there in your experiment or in your survey, right? And you can just argue with using your intuition or your logics. Okay, so Rex theory 4.3. A survey of university dining services is done at lunchtime in a busy cafeteria, right? So is this an SRS, simple random sampling? Definitely no. Because first of all, they just serve the survey on lunchtime. So maybe it is one of the example of convenience sample, right? Because if they want to survey on university dining services, then they need to reach all the people who uses the, there is sample of all the people using the dining service. But if you just go at lunchtime at the busy cafeteria, then maybe there are some people who uses the other ones. For example, in case of TAMU, there are a lot of dining services, not only cafeteria, but pizza, dining hall, or some other places. So they do not care about such a people. So there are some people who do not use the cafeteria. The lunch time. So this is issue of non-response. On the coverage, sorry, not non-response. And also next one is in their own busy cafeteria. So when you just visit the Starbucks in the lunchtime, then there are so many people actually lining up, especially when you go to engineering building about the Starbucks. Then there are literally a lot of people are lining up to wait their copies or something others. Then when you just ask someone that could you do my survey, then definitely people, not much of people says that yes, right? Because they are so busy, especially in the lunchtime. So in that case, maybe there are non-responsive occurs frequently compared with other time, right? Especially when you have some classes, but you need to go cafeteria to get your coffee in 10 minutes, then definitely they do not respond to your survey because of their time issue, right? So in this case, this is related to non-response. Is if buying coffee for 10 minutes before class, something like that. So that's why we don't have some issues on the survey. And next example is about the brand. So all new owners of a certain brand of car that are brought at a particular dealership in town during the past month had their names put into a bowl, right? So at the end of the month, the dealer selected 15 names and sent each a long questionnaire concerning their car. Is this SRS? No, why? Can you see some problems in this survey? So to determine such a question, then you need to set up some kind of assumptions. Yeah. So for example, even if they are not, described in the program, but first thing you can think about is put their names into a board, right? So they just put their name into a board. So if you just assume that nobody changes the name in the board, or nobody just, ruin the board, if we assume that assumption one, if nobody changes the board, during the month. And next assumption to make the simple random sampling is that when you choose your name, then you didn't see the name in the board, right? So if you just see the name, then put someone's name in the board, and if it's not the random sampling, right? So you need to close your eyes and just picking randomly using your hand, then it is the random sampling, right? So when we choose the name randomly, especially without seeing the board, so after choosing those names randomly on the board, having everyone's name with equal chance, then these two assumptions assures that our labeling is great, right? Our labeling and sampling itself is just well done. But to get the sample, we need to get their answers from them, right? So they sent each a long questionnaire concerning their car, right? So to make a simple random selection, random sampling, the assumption 3 is that all the selected dealers, not dealers, owners, sorry, owners answer the questions, right? So if some of the owner doesn't answer your question, for example, if you put 50 names, but 40 persons in the chosen name do not respond to your question, then definitely it is not a good sample, right? Because it contains it is actually voluntary responsive sample. So in the assumption 3, you need to assume that all these selected owners should answer the question, right? So the question. Okay. So yes. So if you have such 3 assumptions that happen, then you can say that the sampling is simple random sampling. Right? Otherwise, if assumption 1 is changed, if there was someone who put out their name in the board, then equal chance, or someone who put the other's name in the copy page of other's name into the board, then it is not evenly distributed. So yeah, definitely it is not a random sampling. Or if your assumption 2 was broken, so if someone who just saw their name and choose the name he wanna pick to bring some people, then definitely it is not the random selection, so it is not the random sampling. And in assumption 3, it was broken, so only 10 people in the chosen owners answers the question, then definitely it is not the random sampling, right? Because we ignore the other 40 people in the sample, so these are all conditions whether making the sampling as a random, simple random sampling, right? So especially if you are interested in some consulting company, it's like a McKinsey or BCG or something like that, then they give you not this kind of situation, but they give you some kind of sort of some situation, and they ask you about what kind of judgment you can do for this given situation. But in that case, what you need to do is just make some assumption on the information and ask your interviewer about the further information you can use for determining some decision, right? So I think that if you're not familiar with this kind of open questions, then please be practice about it so that you can practice a lot on the logic of the interview, right? Do you have any question on these examples or any other in the section? Okay. Okay, then let's call it a day. And since we have a little bit longer quiz, so I will just call it a day right now. So quiz password is data, D-A-T-A, and I will just set it that you can just serve it right now. Okay, thank you very much. And if you have any question, please let me know. So quiz will be over the last lecture and the last Thursday lecture. So it covers the last part of the chapter 5 and chapter 6.
Chapter 7, the last chapter before the next exam.
Yes, in this exam too, we cover chapter 5, 6, and 7.
Is the next exam in like a week and a half?
Oh, yes, we can have. Sorry about that. Good luck. Okay. Pardon? Yes, exact day is, I just checked it. So it is actually, I know the day. It should be October 13th. Yes. No problem. Okay, thank you, Dawson. And is there any other question in Zoom? Okay, then I will close the Zoom session. Thank you very much. And good luck, please.